Hello learners, welcome to the course Statistical Methods for Economics, Probability Axioms 2. In this session, we will discuss the concepts related to multiplication of probability of dependent events, multiplication of probability of independent events, important results on probability of events, solving the problems with multiplication concepts of probability. In the previous module, we had discussed about the axioms of probability such as non-negativity, certainty and additivity. The addition theorem for dependent events and independent events has been stated and then solved the problems related to this concept. Also, we have defined the conditional probability. In this module, we shall know the concepts related to multiplication of probability of events based on whether the event is dependent or independent. We shall now try to understand what multiplication theorem of probability for two dependent events is. Statement: let A and B be two events where the probability of happening of B is dependent on the event A. Then the probability of simultaneous happening of two events A and B is given by probability of A intersection B is equal to probability of A into probability of B given A. Under the condition that probability of A is not equal to 0, where probability of B given A is the conditional probability of happening of B under the condition that A has already happened. Or it can also be stated as probability of B intersection A is equal to probability of B into probability of A given B under the condition that probability of B is not equal to 0, where probability of A given B is the conditional probability of happening of A under the condition that B has happened. Let us understand this with the help of an example. Suppose we have a bag with 5 red marbles and 3 blue marbles. We randomly draw 2 marbles from the bag without replacement. We want to find the probability of drawing a red marble first and then a blue marble. Let A be the event of drawing a red marble and B be the event of drawing a blue marble. As we are interested in finding the probability of drawing a red marble first and then a blue marble, which indicates that A and B are dependent events, because the probability of drawing a blue marble on the second draw depends on whether the red marble was drawn on the first draw. From the given information, we have the number of red marbles in the bag is 5 and the number of blue marbles in the bag is 3. Hence, in total, there are 8 marbles in the bag. The probability of A is 5 by 3 because out of 8 marbles in the bag, 5 are red marbles. Hence, the chance of drawing a red marble is 5 by 8. Now, the probability of B given A is probability of drawing a blue marble on the second draw, given that a red marble was drawn on the first draw. Since we did not replace the first marble, there are now 4 red marbles and 3 blue marbles left in the bag. Therefore, the probability of drawing a blue marble on the second draw, given that a red marble was drawn on the first draw, is probability of B given A is 3 by 7. This is because there are 3 blue marbles left out of the total of 7 marbles remaining in the bag. Using the multiplication theorem of probability for dependent events, we can find the probability of both events A and B occurring together as probability of A intersection B is equal to probability of B given A into probability of A, which is equal to 3 by 7 into 5 by 8, which is equal to 15 by 56, which is equal to 0.2678. Therefore, the probability of drawing a red marble first and then a blue marble is 0.2678. Now, we shall look into some problems and its solution on multiplication theorem of probability for 2 dependent events. A card is drawn from a pack of 52 playing cards. What is the probability that it is a club card known that the drawn card is black? First, let us define the following events for the given problem. Define event A as getting a club card, which implies probability of A is equal to 13 by 52. Define event B as getting a black card, which implies probability of B is equal to 26 by 52. Now, as we are interested to find the chance of getting a club card known that the card drawn is black, we shall look into the intersection of the event A and B. That is, the probability of getting a card which is black and a club is 13 by 52. Now, by multiplication theorem of probability of dependent events, we have probability of A given B is equal to probability of A intersection B divided by probability of B, which is equal to 13 by 52 divided by 26 by 52, which is equal to 0.5. Hence, the probability of getting a club card known that the card is black is 50%. From a population of a town, it is observed that the probability of selecting a male smoker is 2 by 5 and selecting a male is 1 by 2. Find the probability of selecting a smoker if a male is already selected. First, let us define the following events for the given problem. Define event A as a male is selected, which implies probability of A is equal to 1 by 2. Define event B, a smoker is selected. Now, as we are interested to find the chance of selecting a smoker, provided we already know that a male is selected, we shall look into the intersection of the event A and B. That is, the probability of selecting a male and a smoker is given by 2 by 5. Now, by multiplication theorem of probability of dependent events, we have probability of B given A is equal to probability of A intersection B divided by probability of A, which is equal to 2 by 5 divided by 1 by 2, which is equal to 0.8. Hence, the probability of selecting a smoker if a male is selected first is 80%. A box has 3 red and 2 green balls. 2 balls are drawn one after the other. Find the probability that the ball drawn would be red if the ball drawn first is not returned to the box before the second draw is made. From the given information, we have the number of red balls in the box is 3 and the number of green balls in the box is 2. Hence, the total number of balls in the box is 5. Let us define event A as getting a red ball in the first draw. Then, the probability associated with it is 3 by 5. When the ball is not replaced and then getting a red ball in the second draw is the conditional event. Let us define the event B as getting a red ball in the second draw. Then, probability of B given A is 2 by 4. Then the probability of getting red ball in both the draws when the ball first drawn is not replaced to the box before the second draw is made is computed using the multiplication theorem for dependent events. That is, probability of A intersection B is equal to probability of A into probability of B given A, which is equal to 3 by 5 into 2 by 4, which is equal to 3 by 10, which is equal to 0.3. Hence, there is 30% chance of getting red balls in both the draws if the ball drawn first is red and not returned to the box. We shall now try to understand what multiplication theorem of probability for two independent events is. The multiplication theorem of probability for two independent events is also called as theorem of compound probability. Statement: if A and B are two independent events with respective probabilities P of A and P of B, then the probability of simultaneous occurrences of A and B is probability of A intersection B is equal to probability of A into probability of B. Let us understand this with the help of an example. Let us consider an example. Suppose we have a standard deck of 52 cards and we randomly draw 2 cards from the deck with replacement. We want to find the probability of drawing a heart on the first draw and a spade on the second draw. Let A be the event of drawing a heart and B be the event of spade. As we are interested in finding the probability of drawing a heart on the first draw and a spade on the second draw, which is done with replacement, which indicates that A and B are independent events. Because the probability of drawing a spade card on the second draw does not depend on whether a heart card was drawn on the first draw. From the given information, we have the number of cards in the standard deck is 52 and the number of heart card in the deck is 13 and the number of spade cards in the deck is 13. The probability of A is 13 by 52 because out of 52 cards, 13 are heart. Hence, the chance of drawing a heart card is 13 by 52. The probability of B is 13 by 52 because out of 52 cards, 13 are spade. Hence, the chance of drawing a spade card is 13 by 52. Using the multiplication theorem of probability for independent events, we can find the probability of both events A and B occurring together as probability of A intersection B is equal to probability of A into probability of B, which is equal to 13 by 52 into 13 by 52, which is equal to 169 by 2704, which is equal to 0.0625. Therefore, the probability of drawing a heart card first and a spade in the second draw is 6.25%. Now, we shall look into some problems and its solutions on multiplication theorem of probability for independent events. The first bag contains 8 yellow and 3 orange balls. The second bag contains 5 yellow and 6 orange balls. A ball is selected from each bag, where the probability that they are yellow. From the information given, we have the number of yellow balls in bag 1 is 8 and the number of orange balls in bag 1 is 3. Hence, the total number of balls in bag 1 is 11. The number of yellow balls in bag 2 is 5 and number of orange balls in bag 2 is 6. Hence, the total number of balls in bag 2 is 11. Now, we shall define the following events. Event A as selecting a yellow ball from bag 1, which implies that probability of A is equal to 8 by 11. Event B as selecting a orange ball from bag 1, which implies probability of B is equal to 3 by 11. Event C as selecting a yellow ball from bag 2, which implies probability of C is equal to 5 by 11. Event D as selecting a orange ball from bag 2, which implies probability of D is equal to 6 by 11. As the selection of the balls from each bag are independent, in order to know if a ball is selected from the bag, what is the chance that they are yellow ball? We can use the multiplication theorem for two independent cases. That is, probability of A intersection B is equal to probability of A into probability of B, which is equal to 8 by 11 into 5 by 11, which is equal to 40 by 121, which is equal to 0.3306. Hence, we can conclude that there is 33.06% chance of selecting yellow balls from both bag 1 and bag 2. The probabilities of three drivers A, B, C driving home safely after consuming alcohol are 3 by 4, 4 by 5 and 5 by 6. One day, the three drivers drive home after consuming alcohol in a party. Find the probability that all the three drive home safely. From the given information, we have probability of a driver A driving home safely after consuming alcohol is probability of A is equal to 3 by 4. Probability of driver B driving home safely after consuming alcohol is probability of B is equal to 4 by 5. Probability of driver C driving home safely after consuming alcohol is probability of C is equal to 5 by 6. As the drivers driving home safely after consuming alcohol are independent of each other, we can use the multiplication theorem of independent events to compute their probabilities. That is, probability of A intersection B intersection C is equal to probability of A into probability of B into probability of C, which is equal to 3 by 4 into 4 by 5 into 5 by 6, which is equal to 60 by 120, which is equal to 0.5. Therefore, there is 50% chance that all the 3 drive home safely after consuming alcohol. A fair coin is tossed thrice. What is the probability that all the 3 tosses result in head? From the given information, we have noted that a fair coin is tossed. Hence, the probability of getting a head or a tail are equal and is equal to 1 by 2. Now, we shall define the following events in relevance for the experiment. Let A be the event that the first toss results in head, which implies probability of A is 1 by 2. Let B be the event that the second toss results in head, which implies probability of B is equal to 1 by 2. Let C be the event that the third toss results in head, which implies probability of C is 1 by 2. The events A, B, C are results of 3 different tosses and hence they are independent. We can use the multiplication theorem of independent events to compute their probabilities, that is, probability of A intersection B, that is, probability of A intersection B intersection C is equal to probability of A into probability of B into probability of C, which is equal to 1 by 2 into 1 by 2 into 1 by 2, which is equal to 1 by 6, which is equal to 0.1667. Hence, the chance of getting head in all the 3 tosses is 16.67%. Now, we shall look into the important results which are to be known that would be very frequently used in solving the numerical problems of probability. Probability of A dash is equal to 1 minus probability of A. Probability of A intersection B whole dash is equal to 1 minus probability of A intersection B. Probability of A union B whole dash is equal to 1 minus probability of A union B. Probability of A dash intersection B is equal to probability of B minus probability of A intersection B. Probability of A intersection B dash is equal to probability of A minus probability of A intersection B. If A is a subset of B, then probability of A is less than or equal to probability of B. If A and B are independent events, then A and B dash are independent. If A and B are independent events, then A dash and B dash are independent. If A and B are independent events, then probability of A dash given B dash plus probability of A given B dash is equal to 1. For any 2 events A and B, probability of A intersection B is less than or equal to probability of A is less than or equal to probability of A union B is less than or equal to probability of A plus probability of B. Summarization. In this session, we have understood the concept of multiplication of the probability of dependent and independent events, and also we have solved some problems on it, and further discussed the important results associated with the computation of probabilities. Thank you.